Hey everyone, today we are going to be looking at lesson 4.2, constant rates of change. So we're going to be discovering more about proportional relationships. We will be taking examples and solving the word problems together. Let's look at the first question. The bar diagram shows how far one tortilla walks on land over time. Use the bar diagram to determine how many inches the tortilla travels in the third second. Okay, so we can look at this diagram, and what we can infer is that we have 3 seconds, and in these 3 seconds, the tortillas can walk for an average of 10.5 inches. So that means that in 1 second, the tortillas can walk 3.5. In 2 seconds, the tortillas can walk another 3.5. And in 4 seconds, the tortillas can also walk 3.5. But we can do it in another way. What we can do is say 10.5 minus, we're going to add these two, 3.5 plus 3.5, which equals 7. And then that will equal as well 3.5. So now we know that the tortillas can walk 10.5 inches in the 3 seconds, meaning that in 1 second, the tortillas can walk 3.5 inches. So how many inches the tortillas travels in the 3rd second? So the tortillas can travel 3.5 inches in the 3rd second. Okay, now let's complete the table assuming that the tortillas continues to walk at a steady pace. So, when we have 1 second, the tortillas can walk 3.5 inches. So, 1, 3.5. When we have 2, we have 7 inches. So how did I do that? So what I did was that we know that 1 second, the tortillas can walk an average of 3.5. So in 1 second, 3.5, so that means we're going to multiply it by 2 to find the distance in 2 seconds. So 3.5 times 2 is 7, or 3.5 plus 3.5 is 7. And then tortillas in 3 seconds, we're going to add another 3.5, or multiply 3.5 by 3, will give us a 10.5. Now let's look at the 4th second. How many inches can the tortillas walk in 4 seconds? So we have 2 ways to do it, as I said. What we can do is multiply 3.5 times 4 to find how much the distance that he will walk in 4 seconds, and that will give us 14. So in this case, we're going to put 14 here. Or what we can do is use common math, and we know that in 2 seconds, the tortillas walks an average of 7 inches. So since what we can do is multiply 2 by 2, which will give us 4, and also multiply 7 by 2, which will give us 14. But the easiest way as well is just to multiply regularly. And this is what we're also going to do to figure out the distance that the tortillas walks in 5 seconds. So what we can do over here is just multiply 3.5 times 5. So 5 times 5 is 25. 5 times 3 is 15 plus 2 is 17. Then we're going to put the decimal point. So what we can do is 17.5 inches can be traveled. And there's also another way, is just to add 14 plus 3.5, which would also give us 17.5. Either way works. Okay. Now we are going to read the directions for part C. For each column of the table, write a rate that compares the distance and the time. Put the distance in the numerator and the time in the denominator. Divide to write the rate as a decimal. Okay, so first of all, we have to figure out which is x and which is y. In this case, the time, which is in seconds, represents x. And obviously the distance will represent y. Okay, now what we are going to be doing is we're basically going to be flipping them so we can find the rate that compares the distance and the time. So what we are going to be doing is we're going to be putting the distance in the numerator, and the denominator we are going to be putting the time. So let's start. So for the first one, we have the distance is 3.5, so we're going to be putting 3.5 in the numerator. Don't forget to switch them. And 1 in the denominator, because we have 1 right over here. Then we're going to divide 3.5 divided by 1 is 3.5. Okay, now let's go to this one. We're going to put the 7 over here. And then the 2 over here. And then what we're going to be doing is dividing, obviously, 7 divided by 2, which will equal 3.5. Okay, we're going to be doing the same thing with this one. 3, we're going to put the 3, and then 10.5 in the numerator. Dividing it, when we divide, you can use a calculator or do the math. When we divide, we will get also 3.5. Then let's move on to this one. When we divide, we put the 14 in the numerator and the 4 in the denominator. We get 3.5. And lastly, what we are going to be doing is putting the 17.5 in the numerator, and then the 5 in the denominator, and then we can divide and we will get 3.5. So as you can tell, we have 3.5 for all of them. Okay, so now that we know how to set up the writing the rates in a fraction form by dividing, what we're going to be doing now is solving D and E. Alright, so part D. What do you notice about the decimal forms of the rates? Okay, so what do we notice? What's new about it? What can we infer about it? Well, we do know that that when we divide the distance by the time, we always end up getting 3.5. So we have 3.5 here, 3.5 here, 3.5, and 3.5, and 3.5 right over there. All right, so what do we notice? We notice that they're all equal. They all give us 3.5, so they are all equal. Okay. Use a unit rate to describe how the distance the tortillas travels is related to the time. So, how do we think that the distance the tortillas travel is related to the time? Well, we can say that the relationship is always constant, because if we follow the rule that the time is 1 and the distance would be 3.5, and we keep doing it just with different time seconds and we change the distance, we notice that the relationship is constant between how far the distance that tortillas travels and related to the time that he travels. So we can infer that the relationship is constant. Alright, so we learned how to interpret a bar diagram and look at how many seconds in the inches, also complete a table, and do it how we can divide into fraction form. And as we can see, we all got 3.5 here and 3.5 here, 3.5. And we notice that they are all equal. They all give us 3.5. And we can use the unit rate to describe that the relationship is constant. Thank you all so much for watching this video. Don't forget to give it a thumbs up and tell me any other lessons that you would like me to explain. Thank you.